Hello students, in this video we will study the continuation of the sets. In the last video we have studied the definition and some problems of the sets, right, and the empty set also. In this video we will study the finite and infinite sets. The finite and infinite sets. The word itself telling that finite set. Think, what do you mean by finite set? Finite means limited, countable. Limited and countable. It means a set which contains countable number of elements. A set which contains a definite number of elements. A set where the elements can be countable. The elements are definitely countable, then the set is called as the finite set. Indirectly I can say a set which contains finite number of elements. Finite itself telling that it is from some number to from some number. It's a finite interval. It's a finite number. It's a finite elements. Therefore, a set with finite number of elements, with definite number of elements, is said to be finite set. In other case, if the elements are infinite, if the elements are infinite, then the such set which contains the infinite number of elements is called the infinite set. The set which contains indefinite number of elements, infinite number of elements, uncountable number of elements is called the infinite set. Okay, so let's see the definition. The definition is a set which contains definite number of elements. A set which contains definite number of elements is called finite set. Is called as the finite set. It must contain some definite number of elements. The number of elements must be countable. The number of elements must be countable. We must be able to count how many elements are there in a given set. So in that case, if we are able to count the total number of elements in a given set, then such set is called finite set. Such set is called finite set. For example, the set A. The set A contains the natural numbers. X is a natural number from 1 to 15. This is an example of finite set where the set X, set of all X says that X is a natural number from 1 to 15. Now you can see the numbers from 1 to 15 are countable. We can't say that we don't know how many number of elements, uncountable number of elements are there between 1 and 15. No, there are 15 elements are there. We can exactly count. We can exactly count the total number of elements from 1 to 15. It means there are totally 15 elements are there. Then 15 is a countable number. 15 is a definite number. 15 is a countable number. Therefore, this is an example of the finite set. One more example. The set B is equals to X, set of all X, such that X square minus 4 equals to 0 and X is a real number. X is a real number. We can see X square minus 4 equals 0. The solution of X square minus 4 equals to 0 will give rise to X square equals to 4 and X equals to plus or minus root of 4, which is equals to X equals to plus or minus 2 square root of 2. It means X can have either minus 2 and plus 2. See, you can see minus 2 and plus 2 are the definite number of elements. It means indirectly this set is nothing but minus 2 and plus 2. You can see this is a definite elements are there. Therefore, this is an example of finite set. Finite set. One more example. The set C. The set of all X says that X is the number of boy students in the class 11. You see, this is one of the examples that C is a set of all x's, that x is the number of boys students in the class level. You can see in your section or in your class or in your division, there are definite number of students are there. Definite number of boy students are there. We can't say that, sir, this is a classroom where number of boys are indefinite, uncountable boys are there in this class. No, the boys may be some 10 or 15 or 20 or 50. Maximum we can count the total number of boys in the class level. Therefore, these are the three examples of the finite set. Three examples of finite set. Similarly, we will be able to give more examples of the finite set. So indirectly, a set which contains finite number of elements. The number of elements, the elements must be countable. You see, there are 2 elements are there. Countable. 2 is a countable number. 15 elements are there. 15 is a countable number. And here see some example. So some number of boy students in the class. The boy students will be 10, 15, 20. It is a special case. It's a special case that if someone made to set an infinite number of students, that is not possible, right? Therefore, generally these are the examples of the finite set. The finite set. And like this, we can give the more examples. Note on this. Okay, students. Next definition is infinite set. So, an infinite set is a set which contains indefinite number of elements. Indefinite number of elements. I can say uncountable. A set which contains indefinite number of elements, is called as the infinite set. Is called as the infinite set. A set where the number of elements are not countable. You can't count the total number of elements. For example, the number of stars in the sky. The number of stars in the sky. Can we count the number of stars? No. No, we can't count, because in the space there are indefinite number of stars in the universe. Therefore, we can't count the number of stars. The total number of animals in the sea, ocean, right now to the human brain, it is countable, but in fact, according to the research, there are infinite number of animals and herbs, shrubs present in the water system. It means there are some examples where the elements are indefinitely available in any of the set. For example, you can see here, example, the set A equals to set of all x such that x is a natural number. You can see x is a natural number. In the set, the x is just a natural number. There is no definite point where we can count the number of elements. So there is no definite end or start to this number. The elements here can start from anywhere, but there is no end. So generally a set which contains the natural numbers without the end number is given and without the initial number is given. So we can take it as an infinite set. It's an infinite set. Next, a set B equals to set of all x such that x is an even natural number. Even a natural number. You can see, if you collect even natural numbers 2, 4, 6, 8, 10 and so on, there is no end. There is no end. It means indefinite number of the elements are present in the given this second set B. Therefore, this second set B is also one of the example of the infinite set. One of the example of the infinite set. Right? So similarly, you can have more and more examples of the infinite sets. Right? Where the number of elements in the given set is uncountable. So indirectly, this is in a swept-builder form. In roster form, if I write that the set of all odd natural numbers 1, 3, 5, 7, 9 and dash dash dash, this so on indicates infinite number of the flow of the numbers. There are infinite, there are many more numbers till without the end number. So we can't decide the end number because it's a continuous flow of the numbers. After 9 you get 11, 13, 15 and so on. So indefinite number of the odd numbers. Indefinite times the odd numbers. Therefore, the set C is definitely an infinite set. One more set, the set D. The set D. From some numbers we don't know, from somewhere else, minus 3, minus 2, minus 1. You can see there are infinite numbers are there. Or you can take the example like this. Or you can start from minus 3, minus 2, minus 1 and so on. You can see this is also one of the examples. Towards the right or towards the left you can think. There are infinite number of elements. Infinite number of elements. Minus 3, minus 2, minus 1, after that 0, 1, 2, 3, 4. The set of all real numbers you can take starting from minus 3, or you can take integers from minus 3 to infinity. So there is definitely this is an example of infinite set. Infinite set. I repeat again, a set which contains indefinite number of elements, a set which contains uncountable number of elements, a set which contains infinite number of elements. Infinite number of elements. The number of elements must be infinite. Then such set is called as infinite set. Okay students, the next definition is equal sets. Equal sets. The word itself telling that equality, equal sets. Okay, the definition is two sets. If A and B are the two sets, if A and B are the any two sets, then these two sets are said to be equal. That is, the set A and set B are said to be equal if and only if the set A and set B has exactly the same elements. The elements which are present in the set A must be present in the set B. It means the same elements of the set A must be present in the set B. It means exactly the A and B have a same and equal number of sets. Same and equal number of sets. Then those two sets are said to be equal sets. Right here. That is, if A and B are any two sets, then A is equals to B, the set A is equals to B if and only if A and B have exactly same elements. You can see if A and B are any two sets and we say that set A is equals to B if and only if the set A and set B have exactly the same elements. Exactly the same elements. Then in this case we can say that the set A and set B are equal. The examples are the set A contains 1, 2, 3, 4, 5 and the set B contains 5, 4, 3, 2, 1. You can see, you can observe both the sets. The set A contains 1, 2, 3, 4, 5 and the set B contains 5, 4, 3, 2, 1. You can observe clearly that both the sets have the same elements and exactly same elements and exactly equal elements. You can see 1 present in both the sets, 2 present in both the sets, 3 present in both the sets, 4 present in both the sets. Similarly 5 present in both the sets, exactly same. Then in this case, the set A is equals to set B, equal sets, or I can say equality of the sets, right? So here A set and B set are equal, A set and B set are equal. One more example, this is one first. One more example, the set A equals to the set of all x such that x is a natural number from 1 to 10. X is a natural number from 1 to 10 and the set B which equals to set of all x such that x is a natural number and x is less than or equals to 11, you can say. Less than 11 and less than or equals to 10, you can say. You can observe both the sets. In these two cases, the set A, the elements of the set A and the set B are exactly the numbers from 1 to 10. You can see set of all x such that x is a natural number, x is less than or equals to 10, it means x may be 10, less than 10 may be 10. So here also from 1 to 10, see from 1 to 10 is here the set A is equals to set B. Okay, so these are the examples, and still you can produce, still you can elaborate, still you can give the more and more examples on the equality of the sets, and we have some problems on the equality of the sets, finite sets and infinite sets. We have to recognize which set is finite, we have to find which set is infinite, we have to find which set of the sets are equal, which set of the sets are equal. Okay, note on this. Okay students, so let us start the exercise. The second exercise 1.2. The first question is, which of the following are examples of null set, or you can say void set or empty set? Okay, we know that a null set, a void set, an empty set is a set which is empty, which contains no elements. Okay, so we have to find which of the given example is a example of null set, empty set or void set. Okay, first we can read the first question. Set of odd natural numbers divisible by 2. The set of all odd natural numbers divisible by 2. Okay, can you tell me what are the odd numbers? The numbers which are not divisible by 2 are called as the odd numbers. Okay, the numbers which are not divisible by 2, they are called as the odd numbers. But what he is asking, he is telling that there are some numbers which are odd and which are divisible by 2. It means clearly, very good, which is clearly there are no elements, which are odd and which are divisible by 2. It means the division of odd numbers by 2 is not possible, and definitely the first set is an empty set. It means that the solution is the given set is empty. The set is empty. The reason is because we know that the odd numbers are the numbers which are divisible by 2. The numbers which are divisible by 2, they are the even numbers, and the numbers which are not divisible by 2, they are called as the odd numbers. It means odd numbers cannot be divisible by 2. It means indirectly he is telling that there are some odd numbers which are divisible by 2, which is not possible. Therefore, the set is empty. The set is empty, and the answer is the first set is empty set. Look at the second example. Read the second question. Set of even prime numbers. Tell me what are the even prime numbers? In the list of the prime numbers, the only even prime number is 2. It means the set is containing 2. The set containing 2. It means you can see there are some elements, at least one element. Therefore, the given set is not empty. So this set is not empty. Another set is having the element 2. Third example. The set of all x is such that x is a natural number which is less than 5 and which is more than 7. The numbers which is less than 5 and more than 7. Okay, we know that the numbers which are less than 5 are not more than 7. The numbers which are less than 5, why they will be more than 7? The less than 5 numbers are just behind the 5, they are not more than 7. It means the numbers which are less than 5 and more than 7 is not possible. There is no such number where we can say that yes, this number is less than 5 but more than 7. Right? Therefore, the given set is clearly empty set. The given set is empty. The set is empty. The answer is, for the third one is, the set is empty because there is no such number which is more than 5 and less than 5 and more than 7 at the same time. Therefore, the set is empty. The fourth one. The set of all y such that y is a common point on any two parallel lines. Y is a common point on any two parallel lines. Tell me what are the parallel lines? Look at the example of railway tracks. Railway tracks runs parallelly to each other. The front two tires are rear two tires of any vehicle, four-wheeler, car, bus. You can see they run parallel. They turn parallelly left, they turn parallelly to the right. It means two lines which never touch each other. Two lines which never touch each other in the plane, in the space, generally they are called as the parallel lines. But what he is telling? He is telling that there is some common point. He is telling that there is some common point which is not possible. Which is not possible. Therefore, what is your answer? The answer is clearly the given set is empty. You can see, I can draw the pictures. See, this is the one line, line 1. Say that there is another line, line 2. So these are said to be parallel. This symbol indicates parallelism. Parallel symbol is the given symbol. You can see this line and this line have some distance d, which is the same everywhere. The distance d between the line L1 and line L2 is same everywhere. Then why the two lines will touch each other? Why those two lines will intersect each other? Definitely they will not touch each other. Definitely they will not intersect each other. It means there is no common point. There is no common point exists between the parallel lines. Therefore, the answer is empty set. Okay, students, the next question is, which of the following sets are finite or infinite? We have to check whether the given sets, the given examples which are finite or infinite. I repeat again that the finite sets are the sets which contain definite number of elements, finite number of elements, countable number of elements, I can say, is called as a finite set. And in another way, if a set contains indefinite number of elements, infinite number of elements, uncountable number of elements, then the set is called infinite set. And in these 5 examples, we have to check, we have to decide which of them are finite and infinite. Look at the first example. The set of months of a year. There are how many months in the year? There are 12 months in the year. January, February to November, December, there are totally 12 months in the year. Are they finite number of months or they are infinite number of months? Definitely they are finite, because we can count the number of months. First month January, second month February to the 11th month November and the 12th month December. It means there are only 12 months are there in the calendar, or you can say in a year. Do you have anyone's calendar which contains more than 12 months? Yes? No. If there is no such calendar which has more than 12 months, it means 12, from 1 to 12, it is a countable number of months. It means the first set is finite set. The first set is finite. Okay? You think again. Do you have any months other than January to December? Everyone have only 12 months. Only 12 months. Therefore, there is no month more than 12, or there are no more months in the calendar. Therefore, it is countable number of elements. It is finite. Second example, you can see the set which contains 1, 2, 3 and dash 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 and so on. Can you guess me where the end is? No one can, because there is no stop, there is no end number. It is flowing towards the infinity, towards the unreachable number. Therefore, no doubt the given set is infinite set. The given set is, the second set is infinite set. Look at the third set. Look at the third set. The set which contains 1, 2, 3 dash 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 up to 99 and 100. Up to 99 and 100. Whether we can count the elements from 1 to 100 or not. Definitely it is possible. It is possible to count the numbers. We can count from 1, 2, 3, 4, 5. 99, 100. There are totally 100 elements are present in the given set. It means it is restricted. The starting number we know, end number we know. We can count each number between the given numbers. Therefore, the answer is finite. The answer is finite. Definitely this set is finite set because if the starting number we know and the end number we know, the countable number of elements are present in the given set. Fourth one, the set of positive integers greater than 100. Yes, there are more numbers present after the 100, 101, 102, 103, 104 and dash dash dash. What is this? Finite set or infinite set? Definitely infinite set. Definitely infinite set because after the 100 you can go to the any numbers more than 100, right? So it is infinite set. The answer is infinite set. Fifth one you can see. Fifth one. The set of prime numbers less than 99. From 1 to 99. From 1 to 99. We can count the number of prime numbers. We can count the number of prime numbers. It means the answer is finite. What are the prime numbers? The numbers which are divisible by themselves and the 1. The numbers which are divisible by themselves and the 1, they are called as the prime numbers, and definitely there are finite number of the prime numbers from 1 to 99. It means the answer is finite.